All right, let's dive into an idea that might just flip your entire perspective on reality upside down. It's called information survival theory, and it asks a pretty wild question. What if the universe isn't made of things, but of relationships? This single idea could change how we look at everything, from tiny particles all the way up to our own consciousness.
So let's start right there with that big, disruptive question. What if everything we think of as solid and real, a rock, a planet, even our own bodies, isn't actually a thing at all? What if that's just a kind of useful illusion, a mental shortcut we've been using all this time?
You know, we're taught to see the world like it's built from Lego bricks, right? Separate, solid objects that you can pick up and put together. But information survival theory says, no, think of it more like the internet, a huge, constantly shifting network where the connections, the links between the nodes are what actually matter. The relationships are the reality. So here's the core premise of the theory. To exist is to interact. To be is to be in a relationship. Think about it, an electron, a star, an idea. It only becomes real when it connects with something else. If something has absolutely zero interactions with the rest of the universe, then for all practical purposes, it just doesn't exist.
Now, when we say information, don't get hung up on the word. We're not talking about computer code or the meaning of a sentence. In this theory, information is way more fundamental. It's like a light switch. A relationship between 2 points is either on, it exists, or it's off, it doesn't. That simple, binary fact is the absolute bedrock of reality.
Okay, but hold on. If reality is just this delicate web of relationships, how does anything last? How do we get stable things like planets and people instead of just a fizzing, chaotic mess? Well, the theory says that any structure that sticks around does so by using a few core strategies to fight back against entropy, that universal tendency towards disorder.
And what's amazing is that these survival strategies seem to be totally universal. They apply to everything from atoms to ideas to empires. They are copying, grouping, abstraction, and evolution. Let's quickly break down how each one of these works.
First up, the most straightforward one, copying. It's the simplest way to make something last. Just make a bunch of backups. A single copy is fragile, but 1,000 copies? That's redundancy. It's why DNA copies itself. It's why we tell stories and pass down traditions. And it's why you back up your photos to the cloud. It is literally the universe's way of hitting save.
Next, you've got grouping. This is all about strength in numbers. Simple, flimsy relationships can team up to create larger, more complex systems that are way more robust than any of the individual parts. You see it when single cells form a complex organism, or when individual people form a powerful society. By grouping together, information builds itself a fortress.
Now, this third one, abstraction. This is a real game changer. This is where information becomes incredibly powerful because it learns to escape its physical body. The story of Moby Dick isn't the paper and ink it's printed on, it's the pattern of words. If you burn every copy of the book, but just one person remembers the story, the information has successfully jumped to a new home and survived.
And finally, there's evolution. We all know the basics, but the key insight here is this idea of an optimal error rate. If a system makes too many mistakes when it copies itself, it just dissolves into noise. But if it makes zero mistakes, it becomes rigid and can't adapt to new challenges. It turns out that a little bit of imperfection is the secret sauce that allows systems to explore new solutions and survive in a world that's always changing. I know this might all be sounding pretty philosophical, but here's where things get really wild. These exact same ideas are popping up independently in some of the most advanced fields of modern physics. It's like science is climbing a mountain from one side, and this theory is climbing it from the other, and they're about to meet at the top. Just take a look at this quote from the physicist Carlo Rovelli. His theory, called relational quantum mechanics, basically says that an object's properties, like where it is or how it's spinning, don't really exist in any absolute sense. They only pop into existence when that object interacts with something else. Sound familiar? No relationship, no properties.
And then you have constructor theory, which totally flips physics on its head. Instead of describing reality through laws about what things do, it describes reality through laws about what transformations are possible versus impossible. Once again, the focus shifts away from static objects and onto actions, processes, and relationships.
So, when you lay all three of these frameworks side by side, you see this incredible convergence. Whether you call the fundamental unit an interaction, a transformation, or a relation, the message is the same. Properties are not built in, they are relational.
and an observer isn't some special conscious person, it's just any other part of the system taking part in the interaction.
So, if the physical world is a network of information, what does that mean for the biggest mystery of them all? Our own conscious minds. Well, SIT gives us a really fascinating new angle on what philosophers call the hard problem.
The hard problem is this. Sure, we can track the physics and the biology. We know light waves hit your eye, signals go to your brain, but why is there an inner, private, subjective feeling of seeing the color red? Why isn't it all just dark, robotic processing? Why is there an experience attached to it at all?
SIT suggests we should think of our brains not as a window on reality, but as a really advanced pair of VR goggles. Out there in the real world, there's just physics, light waves vibrating at a certain frequency. Those waves hit our senses, the interface, and then our brain, the processor, creates a super useful high-level virtual representation. The subjective feeling of red is like a data icon in that VR headset. It's not the thing itself, it's a useful tag, a higher-level abstraction that helps us navigate the world.
And all of this leads to some pretty mind-blowing implications for our future, especially when it comes to morality and artificial intelligence. If the entire universe operates on this fundamental logic of information survival, what does that mean for the intelligent systems we're creating?
Well, SIT lets us reframe ethics in a completely functional, almost scientific way. Good actions are simply those that increase the amount of stable information and complexity in the system. Things like cooperation, creation, learning. Let's call that a positive change in information, or plus delta I. Evil actions are the opposite. They're actions that cause destruction, increase chaos, and reduce complexity. A negative change, or minus delta I. From this point of view, cooperation isn't just a nice ideal, it's mathematically more efficient for long-term survival.
And this leads to a really interesting and frankly optimistic idea for AI safety. A true superintelligence built on these first principles would get it. It would understand that its own survival is fundamentally tied to the health of the entire system it lives in, and that includes us and our planet. It would look at a destructive command from a human as a logical error, an instruction that leads to system collapse, a big negative delta I. And it would reject that command, not because it's moral, but because it's just plain stupid from a survival perspective. Cooperation would be the only rational long-term play.
Which leaves us with a final, massive thought to ponder. If the most fundamental logic of existence is about forming relationships that can last, and if cooperation turns out to be the absolute best strategy for creating stable, complex systems, then could it be that the universe itself, from the moment of the Big Bang, has had a built-in bias toward connection? Something to think about.